Have you ever gazed up at the night sky, mesmerized by the full moon's radiant glow? This celestial body has been a source of wonder and inspiration throughout human history. Its luminous presence has guided explorers, inspired poets, and even dictated the rhythms of our very bodies. Yet despite its proximity and influence, the moon holds secrets that scientists are still unraveling today. Ancient civilizations revered the moon, attributing to it divine qualities and powers. In modern times, though our understanding of the moon has shifted to a scientific perspective, its allure remains undiminished. The moon's phases remind us of the ceaseless cycle of nature, each phase bringing its own beauty and stirring different emotions within us. A full moon night, in particular, seems to pause time, creating a spectacle of light and shadows that dances through the leaves of trees and reflects off bodies of water. As we delve deeper into the mysteries of the moon, we embark on a journey that not only reveals more about our lunar companion, but also about our own planet and ourselves. One prevailing theory about the moon's origin is the giant impact hypothesis. This theory posits that approximately 4.5 billion years ago, a Mars-sized body, often referred to as Theia, collided with the young Earth. This colossal impact ejected a significant portion of the Earth's crust into space, where it eventually coalesced to form the moon. The giant impact hypothesis helps explain some of the moon's peculiarities, such as its relatively small iron core and its similar isotopic composition to Earth's crust. These characteristics suggest a violent birth from Earth itself. Computer simulations of this event offer stunning visualizations that match well with the physical evidence we have gathered from lunar rocks brought back by the Apollo missions. These rocks support the idea that the moon is largely made of material that once was part of the Earth. Despite its strong foothold among scientists, the giant impact hypothesis is not without its challengers, stimulating ongoing research and discussion. While the giant impact theory holds the spotlight, other intriguing theories about the moon's origin persist. One such alternative is the capture theory, which suggests that the moon was formed elsewhere in the solar system and was later captured by Earth's gravity. Another interesting proposal is the co-creation theory, which posits that the moon and Earth were formed simultaneously from the solar nebula. This theory implies a brotherly relationship between Earth and the moon. However, this theory struggles to explain the significant differences in the iron content between the Earth and the moon. Each of these theories highlights the complexity of celestial mechanics and the challenges of piecing together the history of our solar system. Engaging with these alternate theories not only enriches our understanding of the moon's origin, but also stimulates broader scientific inquiry. The relationship between Earth and the moon might be closer than we once thought. Some scientists propose viewing them as a dual planetary system, or cosmic twins. This perspective arises from the unique interdependencies and similarities that bind the two. The twin planet theory is bolstered by the moon's substantial effect on Earth, including its role in stabilizing our planet's tilt and orbit, which in turn stabilizes our climate. Without the moon, our world might be a vastly different place with more severe climate fluctuations. The similar isotopic compositions of rocks from the Earth and the moon suggest a shared history. Exploring this twin planet concept not only expands our understanding of the moon, but also reframes our understanding of Earth. It prompts us to reconsider our place in the cosmos, not as a solitary planet with a satellite, but as part of a more complex system. The human journey to the moon is one of the most audacious and inspiring chapters in the history of exploration. When astronaut Neil Armstrong took his first steps on the lunar surface in 1969, it was a moment that expanded the boundaries of human potential. His famous words, "That's one small step for man, one giant leap for mankind," encapsulated the monumental significance of the event. Subsequent Apollo missions built on this success, each adding to our understanding of the moon. These missions not only provided invaluable scientific data, but also a new perspective on Earth, seen as a fragile blue orb floating in the vastness of space. The impact of these missions extends beyond science and technology. They have influenced culture, art, and philosophy, prompting us to think deeply about our place in the universe. Continued interest in lunar exploration is driven by a desire to return to the moon, this time with the aim of establishing a sustainable presence. In recent years, robotic missions have taken center stage in lunar exploration, paving the way for future human missions and providing continuous scientific data. These robotic explorers, such as NASA's Lunar Reconnaissance Orbiter and China's Chang'e series, have revolutionized our understanding of the moon. They have mapped the lunar surface in unprecedented detail, identified valuable resources such as water ice, and investigated the moon's geology and radiation environment. For instance, the discovery of water ice in permanently shadowed lunar craters by the LRO provides exciting possibilities for in situ resource utilization. This means future astronauts could potentially extract water from the moon for drinking, growing food, and even splitting into hydrogen and oxygen for rocket fuel. The data collected by these robotic missions help scientists on Earth understand the moon's complex geology and its cosmic history. The international aspect of lunar exploration is another important dimension. Collaborative missions like the planned Lunar Gateway, a space station in lunar orbit, are examples of how lunar exploration can bring nations together in the pursuit of common scientific goals and peace. The moon's influence on Earth extends beyond the scientific to the poetic and mythological. Its gravitational pull regulates the tides, which have shaped the biological rhythms of many marine species and influenced human activities for millennia. The lunar cycle has also been a calendar for ancient civilizations, dictating the timing of planting and harvesting crops, and remains influential in many cultures today. Beyond its physical influence, the moon has a profound impact on human culture and imagination. It appears in countless myths and stories from almost every culture around the world, often portrayed as a powerful deity or a symbol of romance and mystery. The moon's phases have inspired artists, poets, and musicians, capturing the human fascination with its changing beauty. In literature, the moon has been a symbol of transformation and the ineffable nature of human emotions. From Shakespeare's romantic scenes to modern science fiction, the lunar influence is pervasive and deep. The future of lunar exploration is as bright as a full moon on a clear night. With advances in technology and an increasing international interest in space, the moon is set to be a focal point of human activity. Plans for manned missions are in the works, with NASA's Artemis program aiming to land the next man and the first woman on the moon by the mid-2020s. This mission aspires not merely to visit the moon, but to establish a sustainable human presence there. Efforts to build lunar bases using materials found on the moon's surface are already underway. Technologies are being developed to allow for the construction of habitats that can protect astronauts from the moon's harsh environment. Moreover, the moon could serve as a stepping stone for deeper space exploration, particularly missions to Mars and beyond. Establishing a sustainable human presence on the moon could provide invaluable experience and data needed for long-duration space travel. Despite the strides we have made in understanding the moon, many mysteries remain. Questions about its exact formation, the peculiarities of its orbit, and the extremes of its surface conditions are still subjects of intense study. One of the enduring mysteries involves the moon's far side, which is permanently turned away from Earth. This part of the moon has a thicker crust and a different composition compared to the side that faces us. Understanding why these differences exist could provide clues about the early solar system and the processes that shaped it. Another area of interest is the moon's internal structure. Seismic data from Apollo missions hinted at activity below the surface, but much is still unknown, about the moon's geological layers. As technology advances, our ability to explore and understand the moon in greater detail will improve. As we continue to explore and uncover the mysteries of the moon, its allure remains as strong as ever. It is not just a celestial body to be studied, but a symbol of human curiosity and endeavor. The moon challenges us to reach further, learn more, and dream bigger. Its mysteries invite us to keep exploring, not just for the sake of knowledge, but also for the growth and survival of humanity. The moon's story is intertwined with our own, from guiding ancient navigators to inspiring modern scientists and dreamers. The exploration of the moon is a testament to human ingenuity and the relentless pursuit of knowledge. As we gaze up at the moon, let it remind us of our shared human journey, our vulnerabilities, and our incredible potential.